Welcome to Notes 3.3. All right, so it's important to keep in mind that as everything happens today, as we talk about these properties of logarithms, that they all come from the fact that logarithms are exponents. So just really quick to remind you, if I take two things that each have exponents and I multiply them together, right, I add the exponents. So I get x to the fifth. If I take two things that each have exponents and I divide, I subtract exponents. So 6 minus 2 gives me x to the fourth. And if I raise a power to a power, I multiply. So 2 times 3, which gives me x to the sixth. All right, so all of that is important because that is where our properties of logarithms come from. So my product property comes from the fact that when I multiply my u and my v together, what I'm really doing is I'm adding my exponents, just like I did right here. And my quotient property comes from the fact that division becomes subtraction. And my power property comes from the fact that when I raise a power to a power, I multiply. So let's go ahead and use these properties to rewrite our logarithms in terms of the natural log of 2 and the natural log of 5. Obviously, 10 is 2 times 5, so I have the natural log of 2 times 5, which means what I really have is addition, because multiplication becomes addition. And notice how they each get their own natural logs. Likewise, division becomes subtraction, so I have the natural log of 5 minus the natural log of 32, but I was supposed to rewrite it in terms of 2 and 5, and I know that 32 is 2 to the fifth power, so I have the natural log of 5 minus the natural log of 2 to the fifth power, and then when I raise a power to a power, I multiply. So my final answer becomes 5 times the natural log of 2. So when this says find the exact value without using a calculator, it means we're supposed to use our properties. So I'm going to first rewrite the fifth root as log base 7 of 7 to the 1/5 power, because we can rewrite roots as rational exponents. And then raising a power to a power, I multiply, so it's 1/5 times log 7, 7. And then we know that log 7, 7 is just 1, because 7 raised to the first power is 1, so I just wind up with 1/5 in the end. The other way to think about this is that these are inverses of each other, so they cancel, and you're just left with 1, which is the property we learned from the previous lesson. Either one can be used for b. If you see it by using the multiplication or the product property, then you would just take and you would turn your power into multiplication. So I get 12 ln e plus 5 ln e, and then ln e cancels each other out because e raised to the e, or e raised to the first power is e, and so this all becomes 1, so I just get 12 plus 5, which gets me my 17. There are a number of ways to do this. Whichever way you feel most comfortable with is fine by me. So by using those properties, what we've been doing is we have been expanding. And expanding means that there is no multiplication, division, or exponents remaining. All right, so you keep going until none of that is left. So for example, this one here, I got a bunch of multiplication going on, so I'm going to turn that into addition. So I get log 3 plus log x squared plus log y. And then I still have an exponent happening, so I got to get rid of that. So I keep my log 3, but now I get my 2 log x, and then I keep my log y. Make sure that the exponent only goes in front of the log of the term that it was with originally. So it would only go in front of the log with the x. It wouldn't get kicked all the way out in front in the original, because it only applies to the x. All right, over here in b, first thing I'm going to do is I'm going to take my radical and turn it into a rational exponent. So I'm going to make this 4x plus 1 to the 1/2 power over 8. And then I'm going to turn my division into subtraction. So I'm going to wind up with ln 4x plus 1 to the 1/2 minus ln 8. And then I'm going to take my power and I'm going to turn it into multiplication. So that's a 1/2 if you can't tell. And then 4x plus 1 minus ln 8. And then this right here is a single term. That plus 1 does not encompass any of the operations we were talking about, so it just stays as is, and we are done. So condensing is just going the other direction from expanding, which means that we want to be left with no addition, subtraction, or coefficients when we're done. So what I like to do is I just like to take and write a single log out front because I know that's all I'm going to wind up with in the end. And then my 1/3 becomes a power. So I get x to the 1/3 power. And then my addition becomes multiplication, and my 5 becomes a power again, so it's going to be times x minus 3 to the 5th. And you can leave it like that. If you prefer, I'm going to draw an arrow down here, you can write log cube root x, because that's really what x to the 1/3 power is, x minus 3 to the 5th, and that's probably the best way to write it in the end. Okay, so moving on to b. Again, same thing. I'm going to write my ln out front, and then I'm going to have x minus 4 to the 4th power, because my 4 becomes a power, and then my minus becomes division, and I get x squared on the bottom. And we're going to go ahead and leave it like that and not multiply that x minus 4 all the way out, because that would be painful. Just make sure that in the end you have a single log or a single natural log. Whatever you start with, there should only be one of them in the end. A lot of kids want to put one in numerator and denominator, and that would be very wrong. All right, so in C, you'll notice that the 1/5 applies to the whole thing. So we're going to do inside the parentheses first. We're going to follow that order of operations, and I'm going to turn my addition into multiplication. So I'm going to keep my 1/5, and I'm going to get log base 3. And it's going to be x times x minus 2. All right. And then we need to take that 1/5 and we need to basically turn it into a power, but I'm going to go straight to the radical since we've already talked about that. And I'm going to go ahead and distribute while I'm under the radical just to totally simplify things. So I keep my log 3. I'm going to, under my 5th root, get x squared minus 2x. And that's my final answer there. All right, I'm not super crazy about this example, and I don't have a calculator at home right now, so I'm kind of out of luck. But if you'd really like to read more about it, go ahead and look on page 242 of your book and look at example 7, and you will understand how to do this problem. So under the old operating system, your calculator only would function in base 10 or base E. And so in order to do logarithms that were bases other than that, you had to go ahead and you had to do something called change of base. Now the new operating system does have the ability to put in different bases. So this is kind of one of those blasts from the past. But I will warn you that this is on the no calculator section of the test. So you should understand how to do change of base. And the change of base is really simple. If I have, let's see, log little a to the x, then all I have to do to convert it to some base, such as base 10, for example, which is the handy one, which is the one we usually go to, you do the log of the big number, and by big number I mean in terms of font size, divided by the log of the little number. And again, I'm talking in terms of font size. Okay, so if we actually go ahead and do it to this one, my first one would be log 16 divided by log 3, and then I may have mentioned that I did not bring a calculator home with me, so you're going to have to go ahead and calculate that yourself. Just make sure that when you put it in the calculator that you go ahead and you put a set of parentheses after the 16, otherwise it's going to put a log inside a log and you get logception, and it's really confusing. So, and again, we would have log 22 over log 5, and you can calculate that yourself also. So this example is just designed to show you that you can do the exact same thing with natural logs and still get the right answer. So I would get the natural log of 12 divided by the natural log of 2, and whatever that answer is, and the natural log of 17 divided by the natural log of 8. It doesn't matter what you're changing the base to, whether it's base 10 or base E. It works the same way for both.